Today's focus is on powers and exponents. The objective is I will be able to apply the properties of powers and exponents. First, we have some vocab. Base is the number that's being taken to a power. An exponent, the number of times you multiply the base times itself. So if we're looking at notation in this example, we have 4 to the power of 5. So 4 is your base. That 5 is your power, or we could also call it exponent. If you were to think about 4 to the 5th power and what that means, it is the number of times you multiply the base of 4 times itself. So 4 to the 5th power means you have 4 times 4 times 4 times 4 times 4. 4 times itself, a total of 5 times. You could then take that and plug it into your calculator to evaluate it. There's 2 ways that you can plug this into your calculator. You could do 4 times 4 times 4 times 4 times 4. So 4 times itself 5 times. Hit enter. That is a bit tedious, so the other way is you could do 4. This button right here is exponent, that little caret button, so to the power. And then of 5, you can see that you get the same thing. So 1024 would be the answer there. Next section of the notes, what do exponents mean? We are, once again, taking a base and we are multiplying it times itself, however many times the exponent tells you to. So if you see something like 2 cubed, 2 is your base, 3 is your exponent, you multiply 2 by itself a total of 3 times. So 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. And then for this one, it's 4 to the power of 6. That's 4 times itself 6 times. So in your calculator, you could plug 4 times itself 6 times, or do 4 to the power of 6 in your calculator, and that would give you 4,096. What we're going to do is practice converting from expanded form, or from condensed form to expanded form. We don't have to actually determine what is the value. We're just rewriting it into this form. For example, if I have 5 squared, 5 is my base. I'm multiplying 5 times itself. It's 5 times itself, a total of 2 times. So this would be expanded form. If you have something like 12 to the 1st power, you just have 12 listed once. You don't have to multiply it by anything. So that means anything to the 1st power is just going to be itself. Here you have 5 squared times k cubed. So we have multiple things here that we are going to be doing. 5 squared is 5 times itself 2 times, times, this is all multiplication, k times itself 3 times. So something like this we could evaluate and plug into our calculator if we wanted to. Something with variables we could not. I'll do this on your own with you as well. So we have a squared, that's a times itself, a total of 2 times, b to the 4th power, so b times itself 4 times, c to the 1st power, that's understood to be to the 1st power, so c is just listed once, and then d cubed, so d times itself 3 times. You are responsible for the on your own, so I'm going to go ahead and move on to the next example. It says write in exponential form. So now what we're going to do is we're going to rewrite it as a base raised to a power. Here I see that my common base is -3. My exponent will be how many times you're multiplying -3 by itself. So 1, 2, 3, 4, 5. That means I have -3 to the 5th power. If you have more than one base, it's all multiplication, so you just do one at a time. Let's start off with 5 since that's the first base I see. There is 1, 2, 3, 4 5s, so that's 5 to the 4th power, times, I see another base of 13. I have 13 times 13, which would give me 13 squared, times, I also have a base of 7. So 7's just listed once. It's understood to be to the 1st power. If you wanted to put a power of 1 there, you could write that in as well. I'll also give you an example 4, where you have variables. It's the same idea. You just take that common base. So I see x times itself 3 times. So I'm going to rewrite it as x cubed. Y I only see once, so you could just put y, or you could write y to the first power if you wanted to. And then z is multiplied by itself twice. You could put the multiplication signs if you want to show this is multiplication between each term. You will be responsible for the on your own. I'm going to go ahead and move on to the next example. So in the next example, what we're going to do is we are going to practice using our calculators, which I did mention as well. To do exponents in your calculator, you use what I call the caret button. So that's this button right here. That's what we want to use on your TI-30X if that's what you have. All you have to do is plug in exactly how you see it. So it's 5 to the power of 4. You plug in your base first, so 5. You hit that caret button. That gives you your exponent to the power of 4. Hit enter. 625 is the answer. Some people get confused when they plug in fractions, so I do want to talk about that. Sometimes the fraction button is helpful, but it doesn't work all the time. So what I would rather have you do is use division to represent your fractions. You do showing a grouping, showing a fraction, parentheses, 1 divided by 3. So again, I hit 1 divided by 3 to get this. Close my parentheses. So this grouping shows that whole thing is going to be raised to the power of 4. Hit enter, and then it gives you this decimal. If you don't want to put a decimal, if you ever want to convert it from a decimal to a fraction, there is buttons that you can push for that. You hit second, PRB. This will pop up. F to D means fraction to decimal, and vice versa. So you get 1 over 81. That's what I want to see here. I would prefer fractions over decimals here. The on your own is for you to practice by yourself, so I'm going to go ahead and move on to the next one. It says, now how do you negatives change things? Because it absolutely matters where the negatives are placed. So we're going to go ahead and work through these. 3 to the 4th power should be pretty easy. You would just plug it in exactly as you see it. So if I plug that into my calculator, 3 to the power of 4, I get 81. Now this one, this is a negative 3 to the 4th power. That negative out front means you are negating your answer. So if I have negative 3 to the 4th power, that is a negative. I already know that 3 to the 4th power is 81. I'll also show you your calculator to do that. Here's your negative button, so you hit negative 3 to the power of 4. To see this, you hit enter, you'll see that negative 81. Now this is very different. This one had a negative on the outside, so you had a negative answer. This has a negative on the inside of your parentheses. So that is showing that negative is a part of what's being raised to the 4th power. So what you're going to have to do is parentheses negative 3, close your parentheses like that. Then you plug into the power of 4. So again, this negative is a part of what's being raised to the 4th power. You must have those parentheses there. And now you can see it's a positive 81. Let's take a look at number 4. Fractions do usually confuse people, so I do want to talk about that. How you do it in your calculator is just division. So I want you to do parentheses, and then you're going to type into your calculator 1 divided by 2, and then close your parentheses. So it looks like this. Then you can hit to the power of 3. Again, I don't want you to put a decimal. I want a fraction, so we're going to hit second PRB, hit enter. That gives you 1/8. Now this one is the same thing, we just have a negative out front, so just like this one, that means you negate your answer. And once again, this one, we have a negative inside, so when we're plugging it in, we want to do parentheses, negative 1 divided by 2, close your parentheses to the power of 3. Now this time, we have a negative, remember that'll give us a 1/8. So why is this one a positive answer and this a negative answer? Well, this one, you had a negative number raised to an even power. Anytime you have a negative raised to an even power, you will have a positive solution. Anytime you have a negative raised to an odd power, you will have a negative solution. That deals with the idea that 2 negatives makes a positive. If you had 4 negatives in this case, 2 negatives make a positive, 2 negatives make a positive, you have a positive answer. Here you had 3 negatives, so 3 negatives, 2 negatives makes a positive, but if you multiply by a negative, you're going to get a negative still. Moving on to example 7, it says write each number as a power of the given base. So we're just practicing terminology here. The base is 4, and then 16 is going to be your answer. So you're kind of working backwards here. It's saying 4 to what power would give you 16. So 4 times itself, how many times would give you 16? Well, 4 times 4 is 16, so it's 4 to the power of 2. I'll do some more with you because these are more difficult. This one is saying 2, a base of 2 to what power will equal 8? So if I'm thinking about that, 2 to the first power is just 2, times 2 is 4, times 2 is 8. So that would be 2 to the third power. We'll do it again. 3 to what power gives you 81? So it's 3 times 3 is 9, times 3 is 27, times 3, 81. So it's 3 to the fourth power. The rest of them, I think you should be fine to do on your own, but I do want to actually talk about on your own 16. This is saying 3 to what power gives you that 1. You learned this in Algebra 1. Anything to a certain power will give you 1. That is 0. So anything to the 0 power is equal to 1.